Good morning, good afternoon, and good evening to all the participants who joined across the time zones. Thank you for joining the webinar hosted by Marlabs. And today's topic is test automation on the fast track with AI. Myself, I am Siva Prasanna Vanapalli, and I head the quality engineering and DevOps practice at Marlabs. And today I am with Dan and Brad, and we are hosting this webinar from Marlabs side and with our partner Functionize. And we'll have a quick introductions from Dan and Brad.
Thank you, Shiva. My name is Daniel Gannon. I'm the Vice President for Global Alliances and Channels for Functionize, and work closely with Marlabs team to bring AI solutions to market. Brad?
Yes, my name is Brad Calloway, Director of Solution Architects here at Functionize. Work with Dan and Siva quite closely on our joint customers, and I'll be providing the product demonstration today. So Siva, with that, I'll let you go ahead and kick things off.
Thank you, Dan, and thank you, Brad. And thank you, everyone, for joining our webinar today. And we'll get started. And today's topic, as we discussed earlier, test automation on the fast track with AI. And the agenda today would look like this. We're going to quickly talk about what we're covering in the webinar, and then quickly address around some of the challenges in the software testing lifecycle and with the test automation currently, and how do we anticipate to fast track those and bridge those gaps with AI. And we'll also look at some of the potential players in the AI space right now who are doing the quality assurance and test automation related. And then we'll have the introduction about Functionize, and then see how Functionize can really help some of the challenges that we are seeing in the market right now. Before we get started, a quick obligatory pitch about Marlabs. Marlabs is founded in 1996. It's headquartered in Piscataway, New Jersey. We're about 3,000 associates globally, and we're a CM level 5 company with having a lot of partnerships with different companies, tier 1, tier 2, and across the globe. And we have our delivery centers, in USA primarily, but also in India, Mexico, Canada, and Germany. Having said that, one of the service verticals that we have is quality engineering and DevOps. And as part of quality engineering services, we do quite a lot around strategy consulting and end-to-end services across all types of testing. But we are specialized in DevOps and continuous testing, and also in the automation and performance testing space. We have a few other internal verticals and service channels like security, infra, mobility, and DI, data warehousing and all. But we partner with those practices, and we deliver end-to-end customized solutions for all our customers. Having said that, let's jump right onto our webinar topic. Just to give a quick background, there has been a lot of influence of Agile and DevOps over the last couple of years on the quality assurance. And the timelines in which the QA has to be done is actually significantly shrinking down with the increased number of release cycles. With that said, there are quite a few challenges in terms of maintaining the pace at which the test automation cycle is going on, and the velocity at which the features are being released, and the velocity at which the development cycles are going on. Even though we have a lot of tools and frameworks in the market to accelerate the test automation and the overall testing life cycle, we still have a lot more gaps in terms of the scripting times, maintenance cycles, and the reusability components, different tools and technologies, resource challenges. With all those, there is still a lot of gaps. And we're looking at how we could leverage AI and machine learning in this space to accelerate those and bridge those gaps. And that's exactly the topic for today. And having been in the industry for a while, myself about 15 years, and Dan and Brad, a little longer than that, what we have seen is, we have started a lot of projects, up until like 90s and Waterfall, then Agile came in. A lot of focus around automation right from the beginning. Started with probably the nonlinear automation, doing Excel macros and some, batch scripting, SQL loaders and all that. But with right after that, we started having a lot more prominent test automation tools, like, from Mercury and, IBM. They started with, fewer initial pioneers in the market in the test automation space. And there comes a lot of frameworks in terms of bringing a lot of reusability and a reduced maintenance. But with that all said, there's a lot of focus and shift has changed with Agile came into picture and DevOps in the last couple of years. Even with continuous testing now, with a lot of emphasis around the frequent release cycles, there is a lot more need in terms of how we could make it more collaborative, testing with the rest of the product development lifecycle, and also the amount and the frequency in which the features can be tested. So having said that, we're always looking for what's next and what's next that could actually make a quick impact on the results. So let's take a quick pause here, and we have two questions back to back about 30 seconds each, and let's take a quick poll to see how and what some of the responses would look like. So we have 30 seconds. This is the first question. Please select one of the options. The question is, what percentage of your test cases are automated? We have about 15 more seconds. And about 5 more seconds. And good. So the results are, under, about 41% says under 24%, which is, I think, predominantly very consistent with what we are seeing in our organization as well as across the industry. And about 13% says none, no test cases, which is again not surprised. We'll cover these, these poll results in the coming slides, but let's take a look at the second question as well, which is, what are your primary challenges when it comes to test automation? We have about 15 more seconds. About 5 more seconds. And we are up. So the frequent code changes, came up to 60%, which is again, pretty consistent. And team skills and releases are also online. So we'll talk about these as well. The results at least look very consistent with what we are seeing across the industry. So if we quickly go back to the topic and let's look at the impact of release cycles, right? A lot of organizations want to have a frequent releases, at least one release a month and two releases, at least, two releases a month. That's where a lot of organizations are aiming to. But the actuals as such, we're only seeing about 20% organizations are able to achieve that, while a lot are still at the 2 releases per year, which is significantly less. But the primary reason that we are at least seeing internally across, about 200 plus projects internally at Marlabs is the bottleneck is QA, because we get a very limited amount of time. And of course, the hot fixes will get released quickly. But for most part, we have very limited time to do the quality assurance to the extent that is originally planned. So having said that, there are also some challenges with the effort and budget, about 33% being cut down. So with all this, QA being one of the bottlenecks, and we know that QA automation is probably the better solution. But when it comes to QA automation, some of the challenges are, it's automation project is not just something that you can envision today and the test automation scripts are ready tomorrow. The test automation project is just like a development project, right? We all know that. You have to design a framework that would actually take about 25% time. And then you have to refine your manual test cases. You got to script those test cases with whatever programming languages and across the tools. Then you got to execute to ensure they're working across the browsers, across the operating systems. And once they are in, you got to maintain them as and when there are changes to the functionality. I mean, you got to update your scripts, and you got to keep maintaining as an ongoing basis. So if you look at the time taken across the projects, the framework would take about 25%, the scripting would take about 40%, and then ongoing maintenance would take about up to 25%. So these are the major activities that are actually taking time, which is why even if there are a lot of organizations have automation in place, they're not able to keep up with the pace at which the release cycles are happening. And few other challenges: there's too many tools in the market, UFT, RFT, Selenium. Within Selenium, there are too many variations again. A lot of different tools and different programming languages. So having resources and identifying the right tool across the technologies and the right set of frameworks is always challenging. And another biggest challenge that we have seen is about the expectations of the tester. So the tester has started more like a manual tester, a decade ago or a few decades ago. Then the role has changed to support automation. And then now, there's a new word in the last 5 years, probably the SDETs, the software development engineers and test. So the role of a tester is more changed like a developer, because the expectation is the automation is an integral part of the testing, and every tester is expected to do automation. But is that sustainable? Can everybody do programming, and can everybody really hit the nail to bridge the gaps that we have in the software testing? So we have solutions. Probably that's where AI would come in. But having said that, the continuous testing is expected to solve some of these problems, primarily around doing a lot of automation and integration with those DevOps cycles like continuous integration and continuous delivery, CI/CD. But a key point here is automation is everywhere. It's not just with test scripts, from the functional or regression standpoint. We got to look at, the test automation across unit testing, automation across the code quality, static and dynamic analysis, API and different layers, and different mockups and different deployments and operations monitoring. So automation is everywhere, and QA automation is probably one among them. When you look at it from a continuous testing standpoint, automation has to be done across all different levels, and yet we still need a consistent, reliable, and a fast-paced solution when it comes to the software side, the product-based automation at web, API, and QA layers. And that's exactly what we are trying to, address today. And few other challenges: how much to test, where to test. All this would always be there. Having said that, we just want to take a quick pause again before we move on to AI area where AI can help. We just want to see how many are actually being adopting, AI. The question is right now. So do you actually use AI in the software testing today in whatever you do? You have about 30 seconds again. 15, 5, and 2 seconds to go. Time up. So about 80% says no, because that's again consistent. What Marlabs has done in the space is we're kind of one of the early adopters of AI in the the software testing lifecycle, and in fact, for that matter, across the development lifecycle. So we have comprehensively looked at where AI can pitch in, and today I'm not going to talk about how and where AI would pitch in, or how AI can, or what exactly AI is. But today's focus is around where AI can play a role. So before we talk about how and where AI can help, let's look at the software development lifecycle. So there are a lot more areas where AI is expected to help, or at least Marlabs and a few other partners that we have envisioned to look at it. For example, when you're planning about talking about the planning phase, if there is a solution or algorithms that could help with the prioritization, or identifying the story patterns and some of the defect prone areas, across testing, like assistance with automated testing or code generation, unit testing, these are all areas that are inevitable, and those are areas that where we need a lot of help. But specific to today's topic around where the expectations of where AI can help in the QA space, and for that matter, we have been working with the partner, to make sure these are being covered in our offering and solutions. We have seen some of these are reality, what we're going to talk now. For example, test case design. Test case design, like identifying areas based on the user story pattern. Sorry, it looks like there is a glitch with the audio. So, in terms of test case design and suggestions and the test data, management and patterns, we have seen all this being reality. Of course, there is a lot of maturity that has to happen, but it is right out there. We are ensuring that the right use cases are identified and the right set of investment and right set of focus is going on across the areas. And few other suggestions is like, especially with the test automation, how could we accelerate the test design cycles? How could we eliminate the framework design that was actually taking 25% of the time? And how could we, maintain the test cases that we have seen that is actually taking 25% of the time, right? So all these are different areas. And if you look at the suggested methodology, that Marlabs has started implementing across some of our customers, is there are a lot of areas where we used to do it manually and leveraging automation only in the space of regression. But with the solutions with AI, now we could actually scale up the AI and the automation across a few other places, right from the test case creation and right in the system testing level across different tiers and a few other areas as such. If you look at the maturity, there are different levels with no autonomy at all the way to fully, fully being automated. There are a lot of players in the market right now, but mostly at the level 1 and level 2. But hopefully down the road, we're sure this would have a positive impact, and will I'm pretty sure together in the company with our partners, we are also able to achieve and mature to that level down the road. I think overall at a glance, before I hand over to Dan about the specific solution, AI has a lot of advantages leveraging in QA, especially with the risk-based testing, user acceptance testing, and the production analysis with defect preventions and all that. And together by employing AI in the test automation and in the general QA areas, we could probably increase the coverage by about 40% and reduce the test automation cycles by 40%, and eventually the cost also, the overall cost of quality by probably at least 15 to 20%. So that's our hope, and we have already started seeing those results. And a few of the players in the market are these, but today we're going to talk about Functionize, one of the leaders in this space, and who we are partnered with. With that said, I will hand over to Dan. Dan, you'll get the control. Please take it on.
All right, Shiva, it looks like I've got to forward to my slides. There we go. Thank you very much. Can you hear me okay?
Very good, please.
Okay, good. So before I get into the Functionize solution and what makes us different, let me just do a quick introduction to who we are. Functionize is obviously a software testing company founded in 2015 in San Francisco with the express purpose of reinventing the testing process as we all knew it and addressing what we consider to be the classic challenges and problems with widespread high quality adoption and from a testing perspective. And we broke this down into 4 we call pillars, critical areas that we thought we could address in a new way with some new technology, including AI and machine learning, including cloud, et cetera, and some unique proprietary tools and methodologies. And we'll talk a little bit further about those 4 pillars. But we operate globally. Customers are global. Our target market is largely Global 5,000. So we're built and designed for large scale, large volume, mission critical applications. And we're rapidly expanding. So we've got presence in really 6 continents from a customer interaction perspective, and again, growing rapidly. We were the first really to market with an AI-driven autonomous test platform, and so we're proud of being a leader and creator in this industry sector. So let's talk a little bit about what makes us different. We set out from the very beginning, and I like to say that we're revolutionary rather than evolutionary. So rather than look for incremental change, 5% better here, X% better there, we wanted to really reinvent the process and take a fresh look at how things could be done differently. And, we weren't constrained by having an existing framework. And so one of the challenges I think that, legacy vendors have is that, they have an existing product set, existing framework, and it's difficult to go back and weave AI into, those existing kind of products. And so rather than a bolt-on, we've woven AI, machine learning, and cloud technology throughout the process. So I'm going to talk a little bit about how we've done that differently in each of those various sectors. So we were built from the ground up from the very beginning to be what I call application aware. So intelligently understanding using AI, what's going on with an application, how applications are used, the user journeys, and be able to make intelligent decisions automatically based upon that. We're going to talk a lot about how we autonomously identify changes in applications, because again, this is one of those really critical classic problems. How do we do self-healing of tests? How do we determine changes in selectors and XPaths and fix those on the fly with no intervention whatsoever? And when there is significant change in an application, new functionality, new screens, how do we, perform root cause analysis, identify those changes, present those for rapid modification? So, I always like to bring this back to a business perspective as well. It isn't technology for technology's sake, but we focus on what are the operational benefits and the financial benefits from the use of our software. And I'll expand on this a little bit, but as you might imagine, pretty significant. And you can classify this in a number of different ways, but some of our focus is how do we speed the process? And I think that we're all familiar with the demands that modern applications and agile development place upon speed without sacrificing quality. And as testers, I think we probably have all felt felt the pressure of the need to get releases out the door, but not having necessarily adequate time to do a thorough job that we need to. So the way to break that logjam is through technology. So we believe that we can help speed releases, whether it be for new development or application life cycle for production applications, much faster, not only without sacrificing quality, but actually improving quality significantly. We do that by expanding test coverage, by eliminating this bottleneck of maintenance. We can devote a lot more energy to test coverage. We have customers that report anywhere from 100 to even 800% increase in the sort of depth and breadth of their test coverage. And then finally, the cost reduction side. How do we do that? Well, by maintenance and eliminating this huge amount of effort. That effort can be devoted to increased velocity of releases. It can be devoted to other strategic initiatives. So, by eliminating sort of repetitive, non-impactful tasks and devoting that energy to more impactful tasks, it clearly has an impact on the financial performance. When you think about agile development, how does testing play into that process? And we think we've come up with the ideal solution. And I talked about the 4 pillars, and this is where I'll introduce that concept. I've broken it down into, we'll just start with the first, rapid. So for those of us that have been testing for a long, long time, we have all felt the pain of scripting, the process of scripting, the skill set for scripting, the gap that is often encountered between the scripter, tester, and the subject matter expert, the business analyst, the person who understands the application and how we bridge that gap. We use what we call ALP, which is a form of NLP, natural language processing. Ours is more intelligent. It's adaptive, so therefore we've coined the term adaptive language processing. But it enables us to take simple English language test cases. And when I say simple, I mean simple to develop, but yet we can handle any level of complexity from a test case perspective, but using that as our input mechanism. So we've democratized the ability to create tests and expose that now to a wide variety of business users, other people that can define what they need their application to do and behave, and how we have to test to ensure that it works properly. This same test can be used for load and stress testing, and also API testing. So our primary function here is functional testing. The test itself can be widely and broadly used. And then finally, the other input mechanism we have, and this speaks to Shiva's 6 levels, and we believe that we're, essentially at level 4 here, is autonomous test creation. And I'm not going to spend a lot of time on that, but essentially we have the ability to monitor an application, monitor user interactions with an application, and using our AI and machine learning, develop a sense of what sorts of tests should be run based upon those interactions, and present those to a user for inclusion into their test environment. So, self-generation of the test based upon live use of the application and user interactions. So it's really, really, really cool stuff. Secondly, execution is always an issue. And it was interesting. I was just on the phone this morning with a global 100 company based in Europe, and their question to me was, what is the time frame involved executing? And their use case was 1,000 tests. And the response is that I can execute 1,000 tests in the same amount of time that it takes to execute your single slowest test. In other words, it's an asynchronous process. These can all be done at the same time, factoring in test dependencies, of course. And so I can run 1,000 tests concurrently using true cloud scale. So it's a huge sea change in terms of when you develop these really robust, intelligent test cases, what's the execution time and how do you manage the process? Secondly, we realize that our AI-based autonomous test solution isn't an island, doesn't live by itself, and that there are frameworks being developed for CI/CD. And so again, when we developed this technology from the ground up, it was based upon an open framework and an idea that we would peacefully coexist and live in a robust environment and integrate in with virtually all kinds of tools so that we play nice with everything that you have in your environment. The second 2 pillars really deal with how do you maintain these tests over time, and how do we create tests that are resilient, they're relevant. You don't have to go back and recreate them because the application has changed so much that it's easier to rewrite a test than maintain the one you have. So these are classic problems that really consume a lot of time and energy. And so, again, I mentioned this earlier, for substantive changes, where changes are in the actual business logic or functionality of the application, new screens, new functionality, those aren't candidates for self-healing, but have to be examined. We do deep root cause analysis and using AI to give you the ability to immediately and on an actionable basis fix and add functionality to address kind of the new state of the application. And then just as importantly, and Brad will show this in the demo, where we collect literally thousands of data points about every object, every property of every object in an application. We use AI not only to understand the relationship of the object and the object to other objects adjacent and around it, but also we learn from other applications and use that logic to apply to how do we self-heal tests. In other words, for things that have changed, selectors, XPaths, et cetera, to simply examine those, understand that what has taken place, fix them on the fly during the testing process, And we continue to refine that process, and we believe we'll get to zero maintenance in the future. So all of this, wraps up into business results, which is really the purpose for this. And I won't go through all these statistics. You can kind of look at this, but what makes sense if you think about those capabilities I just described, we can have huge impact on obviously maintenance of test process, the time to generate tests, and the skill set and the individuals required to do that. In terms of IT resource productivity, we affect that in a couple of different ways. Obviously, cloud scale doesn't require your own infrastructure to buy, build, and manage. We put that in the cloud. And we also, and Brad will talk about this, we eliminate the need for things like Browser Stack and Sauce Labs because that functionality is contained in our product set. The massive increase in test coverage, both depth and breadth, just ensures a much higher level of quality, less rework, faster engineering process, and just enables you to go to market much, much, much faster. I'm going to give just a really, really high level overview of the platform that we use to accomplish these results, and Brad will go into this much deeper. I already mentioned how we ingest tests. We use NLP, or our version of that, ALP, adaptive language processing, or the other method for test creation, of course, is autonomous test creation, which we do. Those are fed into our adaptive event analysis. This is our version of AI machine learning, and I'll talk a little bit more in some details around what that is and how we apply that to various, those four various pillars. But this is where we do modeling, where we develop all the code behind that after we adjust that. It's fed into the functionized adaptive and event analysis test cloud, which is where execution is performed. And of course, we talked about the ability to look at results and use root cause analysis for those things that aren't self-healed, that require some level of intervention. So very high level view. Brad's going to go into that much deeper when he goes through his demo. We always get questions about the underlying engine. It's interesting to talk about AI. Some people, their AI really is truly artificial. It doesn't exist. And I find that there are companies that talk about that find it easier to re-engineer their websites than re-engineer their product. But in our case, again, as I mentioned, we have built the product from the ground up, from the very beginning, weaving AI and machine learning throughout the process. And as you'll see from this slide, our adaptive event analysis capability, we use different methodologies for different tasks. So as you'll see, for live user analysis, there's a set of methodologies we use, and this is all supported by our own internally developed robust AI methodologies. Different set of capabilities that we use to do autonomous test generation, and yet a different set of capabilities that we use and bring to bear to do self-healing maintenance. So it's an extremely robust engine. It, of course, is continuously learning. We find that our capabilities expand with extraordinary pace every month, and all that's applied to the process. It just culminates in one thing, and I'm not going to go through the details here, but I just found this to be interesting. Gartner said that in 2025, that you'll start to see intelligent testing automation and self-healing of testing. And I think that means that we're considerably ahead of the market because we do these today. So with that, I'm going to turn it over to Brad and let him show you exactly how that's accomplished.
Thank you, Dan. Let me go ahead and take control here. Do want to make a couple announcements here. One, I just had surgery, so I'm performing this left-handed, so apologize if I'm a little slow. Secondly, I'm located in Denver. We're going through a massive blizzard right now, and my power's already gone out a couple times. So if your screen all of a sudden goes blank, do know that it's possible that my power goes out. So as Dan said, I'll be walking you through kind of some high-level features of Functionize, really the four pillars that Dan talked about on the slide that he just went through. What you're seeing on the screen now is actually the Functionize platform. We're actually on the project portal. All these different images that we see here are different projects that we have set up with Functionize. Projects can be set up for whatever reason, right? Could be to support a specific application, could be a specific line of business. Really, it's up to each customer to determine how they want to categorize their tests. I am going to go into this NLP modeling project. And the first thing we're going to look at today is test creation. Now, what you're going to see here is drastically different than what you're typically used to, whether it's a commercial tool like UFT or Tosca, open source like Selenium. The way in which Functionize goes about automation is actually quite simple. We're going to have our users write English language test cases. Our AI platform will interpret those test cases and automatically build automation for our customers. We remove the need to understand programming language. We take English language test cases and convert that into a language that computers can understand and run our automation. So to go ahead and create a new test case with Functionize, I'm going to go ahead and click on this Create New Test. I am going to have to provide some high-level information about my test case, and I'm going to go choose natural text here. I'm going to have to provide the test case a name. We'll go ahead and just call this contact. Starting URL, in this case, it's going to be pipedrive.com, which is a CRM SaaS solution that you might be familiar with. And now I have a couple of pieces of information that I have to fill out that I think are quite interesting and important enough to kind of point out. One of the things that Dan mentioned is our ability to do full cross-browser testing. And what we're asking here is browser run order. So I'm going to have this single test case that I'm going to write in English. We'll convert that to automation, and we'll be able to run that test case across all 5 major browsers, as well as mobile as well. So here we're asking, can I run this test case in parallel, all browsers, all at the same time, or do I have to run it sequentially? Next thing is the test case repeatable. If it's not, do I have a test data management solution where I could call a job through an API to maybe synthetically generate test data for this test case? Or maybe pull data from production, transform it, and now have a new data set to be able to test with. So some really neat capabilities around resetting or pre and post test case steps. Platform type, we support both desktop and mobile. This specific project's only set up for desktop, so I'm going to choose that, and I'm going to give it a quick description here. Now I'm going to go ahead and click on Next, and this is where Functionize asks our users to go ahead and write that test case. What we're seeing here, and I'm not going to go ahead and write one out, just given the fact that we're a little bit limited on time, but we could simply write out our test case directly down here. You can see that first step is already written out for us in the form of open URL pipedrive.com. What you'll see is that we've taken the industry standard format, if you will, and that's the format that we expect our test cases to be written in. Here you'll see we provide a step column. This is where we identify the action that we want to take against the application, typically in the form of identifying the object that we want to interact with and what we want to do against that object, like click a button or enter into a text field or select a value from a dropdown. Next, you'll see we have a test data column. Any test data associated with this test case we provide in this column. With Functionize, we model the test case initially off a single data scenario, but we do fully support parameterization and data-driven testing. So I do have the ability to create an outside data source, such as maybe a CSV or Excel file, or pull data from a database and map that to my actual test script, if you will. And then lastly, any step that I execute, we can always include an expected result. So might want to validate that I logged in, might want to validate a specific page has appeared, might want to do some type of calculation to verify results, whatever it may be from an expected result perspective, we can put it in that column. Just to give you a quick glance at what an actual test case looks like within Functionize, I do have a test case that I've created actually within Excel because we can import from outside data sources. So this is a test case that creates a contact within that Pipedrive application. Now, one thing I want to point out here is we call ourselves adaptive because we don't have a set of keywords like click or enter or select. We allow users to write test cases in a way that they feel comfortable with. And our vision is that we will understand every test case that is submitted to us. Now, in saying that, clearly you want to be as direct and as unambiguous as possible. You're going to get better results out of the platform, but we're not limiting. We accept all test cases. We run that through our AI machine learning process to interpret that test case, and we will convert it into automation. So I showed you this in Excel. To go ahead and import that through Excel, we can use this section up here. A couple other things I want to point out is we also integrate with test management solutions. So if I had these manual test cases defined, say within Micro Focus ALM, or maybe it's Zephyr or Test Rails or Agile Central or even Jira, in most cases, we can ingest those test cases directly through that test management platform. So I don't even have to write them out if I already have them defined. Once I submit my test cases, they do go to the Functionize modeler, and Functionize models the test case, and then we'll return them to you in a, and I'll go to this active tab, and we'll return them to you in a waiting for review status. So this is that same test case that we looked at that I had built out within Excel. And you can see that it returns to us in waiting for review. The reason why we go through a review process is that we're leveraging AI and machine learning to generate automation based on your test case that you wrote. The review process is there to ensure basically that we got it right. So it has you walk through the test case screen by screen, action by action, and validate that the automation we built is actually correct. So if I click on review here, we can kind of take a look at what that process is. I'll just step through a couple different screens because I think it's pretty self-explanatory on how the process works. What we'll see here is that initial pipedrive.com login screen come up, and you'll see I'll be able to step through each individual page and all the steps within that page. So this one actually picking up in the middle of the test case, so we can see a little bit more of the action that's going on within the test case. Here we're entering contact information. We're validating that we put in the correct data element, and we can simply step through each of the different test steps. Now, once I validate that, I close out of the review process, and now I'll have a test case that I can actually go ahead and execute. So I know I went through this pretty quickly, given the time that we have, but a couple of things to point out with our ALP methodology is we have our users write English language test cases in a way that they feel comfortable with. We submit them to the Functionize platform. Functionize will model that test case, return it back to the user in a waiting for review status. And now, once we approve it, now these test cases highlighted in white, we can go ahead and execute. So we really take a lot of the heavy lifting out of our users' hands, and the actual platform, the AI, does that heavy lifting. We just need our customers to submit English language test cases to our platform to build automation. So that's creation. The next thing we're going to take a look at, and that Dan talked about, which was the second pillar, which is execution. And more so not about executing a single or a couple test cases, but how would I execute 1,000 test cases? And how would I execute 1,000 test cases across, say 4 or 5 different browsers that I have interest in? All possible with the Functionize platform. So I'm in a different project here. And in this case, just to keep it somewhat simple, I have 10 test cases, actually 25 if I expand this. I have 25 different test cases. What I want you to look at now is when you look at this browsers column here, you'll actually see that there's icons here for IE11, Explorer Edge, Firefox, obviously Chrome, and Safari. Now, what I want to do in this case is I want to execute all 25 test cases. So in that case, I'm going to go ahead and bulk select all 25 test cases and then choose Run Tests. With Functionize running, in this case, all 125 tests in parallel, all at the same time, definitely possible. And that's what you're seeing executed right here. So the ability to scale execution, the ability to reduce your test cycles while still running all the necessary automation, say within a regression run or whatever it may be, all very possible with Functionize. We don't request of our customers any additional infrastructure. This is all running in the Google Cloud, nor do they need to subscribe to something like Sauce Labs or BrowserStack. That capability is directly available within the Functionize platform. A couple other things I want to point out here real quickly. You can see these test cases executed right now. Running every single test case in a project, probably not a real use case. To set up a real test run, we have the concept of an orchestration. An orchestration allows me to identify the test cases that I want to run. That can be within a project, that can be across projects, and that can be test cases within projects that are categorized, with either with a module or a tag. So the ability to identify those test cases that I want to execute, and then how I want to execute them. What browsers do I want to execute them against? Do I want to run some in series? Do I want to run some in parallel? All that capability is all available within orchestrations through Functionize. These orchestrations that we create here are also able to be executed through something like Jenkins. Here, what we're looking at is some of the out-of-box integrations that we have with what I'll call the usual suspects within CI/CD. So you'll see that we have a number of out-of-the-box integrations, both from an inbound and an outbound. And then the last thing I'll cover here real quickly before we move on is we also have a command line interface. So the ability to execute test cases without needing access to the Functionize UI, definitely available within Functionize. The ability to allow developers to run locally, also available with our CLI. So some pretty cool functionality that really tailors towards the development community using the Functionize CLI. So that's what I wanted to cover on execution. Last thing that we're going to talk about today is maintenance. So as we know, maintenance is a big part of a big part of the cost of automation is the way I'll put it. Obviously, through our NLP or ALP system, there's significant efficiency gains in the creation of automation with Functionize. But I think the biggest bang for the buck actually comes through our self-healing capability as well as our root cause analysis. And I'll touch base on this really quickly because I want to make sure we have time for some Q&A here at the end of the session here. I have a test case here. It's based off an e-commerce site. In this case, we do have a failure at step 17, so we'll look at how root cause analysis will identify, what the issue with this test case. But before I go there, I do want to explain a little bit about our self-healing capability. So when we model a test case, we're not looking to create some simple Selenium script, but we're actually looking to model not only the test case, but really the application. This is a single step within this test case that's doing a verification of a web element. And here you can start to take a look at the amount of information that we're capturing on this single step within this test case. You'll notice that we're identifying parent information, children information, sibling, neighboring information, spatially where the things are, XPath, CSS selectors. We're just gaining a wealth of knowledge about, not only the specific object, but everything pertaining to this object on the screen. And we do this because at runtime, we're able to evaluate this information, see what's changed, and choose the right algorithm to be able to do object identification. And as we see things change, we're actually able to self-heal the test case. So if a selector changes or a label changes or where something is on the screen changes, we can actually update that in real time within the test case. So our test cases are living documents, if you will. We actually take that a step further and can identify other test cases that interact with those same objects. And we're able to update those in real time as well. With Functionize, we don't write the test script and then the only way to change that test script or modify it to change along with the application is through manually updating it. Our AI and machine learning are doing this in the real time. It's a real differentiator for Functionize. The other thing that I'll cover real quickly is something that we call test case insights. This is looking at all the data that we're capturing on the whole entire test case. Remember, this was an 18-step test case, and we can start to take a look at all the different data elements or data points that we take on that single 18-step test case. And then this bar chart up here represents the variance, if you will. So as we know within application, certain attributes are dynamic. And those attributes that are dynamic are less reliable, if you will, from an object identification perspective. If we can keep track of those objects that are, or those attributes that are dynamic, it gives us a better chance of being able to successfully identify and interact with objects in our test case. So, a couple points were made earlier that we significantly reduce maintenance. Well, this is one of the main reasons we can do that because we can adjust in the real time to consistently identify objects. So we don't have the brittleness that has been a problem within functional testing over the last 25 years. So, going to move on to the last topic today, and that's our root cause analysis. I'm not going to go into a lot of detail here given the time we have, but do know that we failed on a step 17 here. The reason why we failed, if I bring up the screenshot, is the item in the cart is incorrect. We expected Levi denim jeans, and we see a blue cocktail dress here. So anytime a test case fails within Functionize, our root cause analysis engine runs. Now, certainly one of the results of the root cause analysis is that it might come back and tell us that we actually have a failure within our application. That's great. That's why we do testing. That's the value of automation. We also run into situations where we've changed the application in such a way that the test case has to be updated to bring it back in sync with the application. And that's the case that we have here. So I'm going to bring the results of our root cause analysis. And what you're going to see, it's going to be providing me a suggestion. It comes with a probability. In this case, we're 90% confident that this is the issue with the test case. And what it says here, it says that Functionize has identified a different set of elements that may be used instead. So essentially what it's saying is that we clicked the wrong button to add the wrong item to the cart in this instance. Now, if I look at this review suggestion, it's actually going to bring me to where the test case went awry. Not where we saw the failure, which was in the shopping cart, but actually the screen where we chose the wrong button. Now, to give you a little bit of background here, a little context, obviously I know the changes that we made to this application on this release, this build of the application. And what we've done is we've moved this entire section down here from up here to down here. We're trying to add these Levi denim jeans, but since we moved this section, changed the name of the button from add to cart to add item, and changed the size and obviously location as well, during execution, we chose the wrong button or selected the wrong button. Functionize, through its root cause analysis engine, has identified that issue and is going to allow me now to update or rebind the right button to this specific step. So to update the test case, I don't have to go back to that English language test case. I don't have to go into any program, any Java, any C#, any VB script, whatever it may be. All I need to do is go ahead and click on that button within this screen, and we're going to go ahead and automatically rebind that step to the correct button. This will update the test case. Now I can re-execute the test case, and I have once again a test case that will go ahead and pass and validate that that this checkout process is working properly. So I know I went through a number of the different features really quick. Do know that if you do have interest, the ability to set up a more detailed demo, a little bit more of a deeper dive, you'll be able to reach out to Siva and get that set up. So with that, Siva, I'll hand it back over to you and we can enter into Q&A.
Thank you so much, Brad, for the wonderful and detailed demo, and thank you, Dan, as well. So with that said, we will open up for questions at this point, and we already have a few questions, already on the panel here, and among me, Dan, and Brad, we will answer each and every question. In case if you're not able to answer any question within the time, we will get back to you through an email. So please feel free to ask any questions. So, Dan and Brad, so the first, question is this. How does the platform support, whether the platform supports Windows or, the desktop and the native mobile applications? Do we have the current support? If not, what does the plan look like?
That's a great question. I'll grab that. The original intent of the platform was to test web applications, modern architecture, SaaS applications. But we have quickly realized that the legacy platforms are part of end-to-end business process validation requirements, and they're not going anywhere anytime very soon. So we have begun the process of adding support for, I'll just call legacy/Windows applications. I think we'll have the first wave of that support out in probably late Q2 of this year, but we have a stated intent to support those kinds of applications in the future.
Thanks, Dan. The next question is, what is the current accuracy rate of interpretation of test cases?
Yeah, so that's a great question, Dan.
Yeah, go ahead.
I don't know that I have the exact percentage. We do track it, and I could go figure it out. I would say, right now we're anywhere between 85 and 90%, with one caveat. Typically, when people first start using our product, it takes a day for them to, get a general understanding of the detail that they need to provide within their test case. Obviously, once they've been trained, have that day's worth of submitting test cases, they quickly realize, what's going to be accepted and what's not. And then at that point, I think, we're, up around the 85 to 90%. So I think really good. And I think as, we collect more data points, we'll get better and better as time goes on. So I think we're really good now, and I think only getting better as well.
Thank you, Brent. The next question is, how does this works in a distributed microservices-oriented environment where there are multiple services integrated that can have multiple points of failures?
I'm sorry, Siva, can you repeat it? I missed out on the first part of that question. Could you repeat the first part?
No problem. It's about the microservices. So how does the platform work in a distributed microservices-oriented environment where there are multiple services integrated together that can have multiple points of failures?
Sure, I would, it would really depend on the actual use case, a more detailed example. We are going to identify, what those, in our modeling process, we'll identify those microservices. We'll have the ability to interact with them if we want to within our test case that we write. But I would love kind of an offline conversation to get a more detailed example of what they're looking for.
Sure, Brad. And, the person who has asked, we're going to get back, to the person with more details and probably follow-up conversations. And a few more questions. Actually, there are quite a lot, but let's try to answer as many as possible. So does the platform integrate with Azure DevOps release pipeline or, Visual Studio TFS related environment?
The answer is the set of APIs that we have will integrate with just about any CI/CD tool. Integration currently with Microsoft Team Foundation Server is not one of our out-of-the-box integrations that we have, but those are all customer-driven. So as the customers ask us for additional integrations, we supply them supply them at that time. So the ability to do it is there, just not something that's there out of the box currently.
Perfect, thank you. How does the platform handle the data-driven tests? And also, how do you feed in data, or does it even allow to feed in data from a spreadsheet or a JSON file while we create the test cases with NLP or adaptive learning?
Absolutely. So as I said in the demonstration, we do model the test case against a single scenario. Once the test case has been successfully modeled, we have a concept called a connector. And a connector allows us to associate an outside data source to a test case. So instead of using that data that we put in the data column within the NLP test case, we can automatically, it will auto-parameterize and then feed data at execution from an outside data source. That can be Excel. I can literally write SQL queries. It could be a YAML or XML file, really any data source that you want. We can go ahead and map it to our test cases to do true data-driven testing.
Sure, thank you. And the next one is, do we handle Opera browser at this point?
Do we handle what again, Steve? I'm sorry.
Opera browser?
We do not. We do not support Opera at this point, but as Brad said, most of these kinds of requirements are customer driven. So, it's certainly possible to add support for it, but it's not supported today.
Okay, thanks, Dan. And does the platform, is it possible to do API automation?
Yeah, so we do have obviously a limited amount of time to demonstrate to you today, but we do fully support API testing as well. And those API tests can be incorporated into our orchestrations so that you can do both functional and API testing in a single test run and share data across them.
Okay, perfect. And a few other questions probably would need deep dive discussions around mobile test automation. Do we need to follow the same process to create test automation scripts for mobile applications on iOS and Android? But I think those are in-depth discussions, and probably we'll touch base with those individuals to have detailed, discussions. With that said, there are actually, probably have like 10 other questions in line, but we only have 1 minute. So as I said, we will get back to you with all these questions. Dan, Brad, and myself will answer and will shoot an email to all of you. We actually are recorded this session, and we are going to also share this session with all of you. With that said, I would like to thank Brad and Dan and for joining this session and presenting a wonderful demo. And I also would like to thank each and every participant who joined right from the beginning and held till the end. And please, we will get back to you with all the questions one more time. And one last request, we have a short survey that comes right at the end of this webinar. Please do fill up and provide us the feedback, and we are hopeful to get back to you in the next couple days. And thank you once again. Good afternoon, good evening for across the time zones. But again, once again, thank you so much for joining and presenting.
All right, thank you.
Thanks, everyone.